In this video, we're going to talk a little bit about how to find the confidence interval for the mean when you know the population standard deviation. So first off, I wanted to kind of review or highlight for you the information that you need in order to find a confidence interval for the mean. And specifically, we're going to be looking for when you know the standard deviation, then you actually are going to determine what we call the Z interval. Okay, so when you have, first of all, when you know the standard deviation, and it's really the population standard deviation, then what you're going to find or create, we refer to as a Z interval, because it is based on the standard normal distribution, which we often use the z-score with. And so that kind of gives you an idea of why it's called the z interval. But to create the confidence interval for the mean, when you know the population standard deviation, you need at least 4 pieces of information given to you in the problem, or you need to be able to find it. The first thing that you need is X bar, which would be or correspond to the mean, sample mean, or the mean of the sample. You also need N, which is your sample size. How many did you have in your sample? You need sigma, which would be your population standard deviation. You need the confidence level. I'm going to use the abbreviation CL for the confidence level. The confidence level is usually stated as a percentage, although it could be written as a decimal. So just be aware of that. And in some cases, if you have a small sample, less than 30, you also need to be told that the distribution or the variable is approximately normal. And that's because, again, we're using the Z interval, and it's based on the normal distribution. So you need to know that your distribution is approximately normal. Now, there's 2 ways these problems can be presented. In one case, you are given those 4 pieces of information outright in the problem, and it's a matter of substituting it into or plugging it into the calculator. The other way that they're presented, I think, is the one that we're giving some of you some difficulty, is where you're actually given the raw data, where you have to actually enter the data into the calculator to ultimately determine one of those 4 pieces of information. So if I read through example 1, it says a simple random sample of 12 iPhones being sold over the internet had the following prices in dollars. And they list those 12 prices. Assume that it is reasonable to believe that the population is approximately normal. Okay, so here it tells us, first off, it is approximately normal. It also told us in the first sentence up here where it says 12, that's my sample size. So that corresponds to N. So then, because that sample is relatively small, okay, they tell you that your distribution or your population is approximately normal. Also, if you continue to read, and it says, and the population standard deviation is 65. And then it says, what is the upper bound of the 95% confidence interval for the mean price of all phones of this type? It wants you to round your answer to 1 decimal place and write only a number. Do not include the units. Okay, so far we know, remember, we need to know the sample mean. We need to know the sample size, which we know it's 12. We need to know the population standard deviation, which again we were given as 65, and we need to know the confidence level, which we're given, it says 95% confidence interval. So my confidence level is 95%. Now, I believe when you go to enter 95% into the calculator, you need to write it in decimal form. So just to remind you, to convert a percentage to a decimal, you would do 95 divided by 100, which is 0.95. Now, in this case, the piece that is missing is our sample mean. But I have the raw data, which would allow me to find it. But my calculator will also do it all at one time for me when I'm using the command for the Z interval. So let me kind of give you those keystrokes, and then I'm going to show it to you on my calculator. Okay, so on your calculator, you would go to Stat, press the button that says Stat. Then I'm going to arrow to the right 2 times to highlight the menu at the top labeled Test. And then when I get to Test, I have kind of a drop-down menu, and I'm going to scroll down to option 7, which is Z interval. And then from there, I can finish out the problem. So I'm going to show it to you actually on the calculator. That tells you how to get there. So let me pull my calculator up on the screen. Okay, I'm going to try to pull it off to the side so you can see the problem and the calculator, hopefully, at the same time. Okay. Because I need to see my data. Okay, so let's go back right here to my data. Okay, so I would press Stat, arrow to the right 2 times. I get my menu, and then I want to choose option 7. So I'm going to press the number 7. And it comes up. And here's the key part here, guys. Notice that you can input, INPT stands for input. You can input either data or the statistics. Well, in this case, I don't have all of the statistics, but I do have the raw data. So I have to back up for just a minute. I'm going to go back to Stat, and I'm going to choose under the Edit menu, number 1. And I'm going to enter my data that was given to me in the problem under L1. So I'm going to enter the numbers 287, enter, 311, enter, 262, enter, 392, enter, 313, enter, 304, enter, 325, enter, 316, enter, 286, enter, 349, enter, 319, enter, and 291. Okay, so now I have that data entered into the calculator. So I'm going back to Stat, arrow to the right, highlighting the menu for Test, choosing option 7. And so I have selected that I want to input the data. So I've done that in column 1. So I'm going to arrow down. I need to enter the population standard deviation that's given in the problem, that is 65. It asked me, where did you put the data? That's the list. I put it in list 1 or L1. So I'm good. Frequency defaults to 1. Please leave it as 1. Then the confidence level. The confidence level we're asked for in the problem is 95%. As a decimal, that would be 0.95. Okay, so it set that as the default. Then I'm going to highlight the word calculate, hit return or enter. And on the very first line up here, it gives me the answer. Okay, so I'm going to write this answer here on my paper. I get 276.14. Okay, so 276.14, comma, 349.69, and those are surrounded in parentheses. It does indicate to me what my sample mean was and the sample standard deviation, as well as the sample size. I don't necessarily need those things to answer this problem. Okay, within those parentheses, you have two numbers that have been output for you. Okay, you have two numbers that have been output for you. The first number would be your lower bound. So the lower bound of my confidence interval, the price of the phone would be $276.14 if you want to look at it that way. And then the second number in the parentheses is the upper bound. And so this question specifically asked me for the upper bound. So ultimately my answer, rounded to one decimal place, would be 349.7. Okay, it's 0.7 because in the first decimal place, there's a 6. Next door is a 9. The 9 will bump the 6 to a 7. So your final answer is 349.7. Okay, let's look at one more. Actually, I've got two more on here. Okay, so the second one says, and I may have to have some space. I may have to write above it. Okay, the second one says a simple random sample of 10 households. Okay, so we start out and it tells us we have 10 households, so that's our sample size, which is N. The number of TVs that each household had is shown as follows. And again, it gives you that list of raw data. Assume that it is reasonable to believe that the population is approximately normal. Again, because we have a sample that's smaller than 30, we need that information. It says the population standard deviation is 0.44, and it asks you what is the lower bound of the 95% confidence interval. In this case, they want you to round your answer to two decimal places and write only. So here again, if we think about what we know, we need the sample mean, the sample size, which we've determined is 10, the population standard deviation, which they give us as 0.44, and the confidence level, which is 95%. So here again, because I have the raw data, when I go to my calculator, I'm going to have to enter that raw data before I can use the z-interval command. So again, I'm going to walk you through how to do that. We need to clear out the one that we entered earlier. Okay, so first is we need to clear out, erase, get rid of the previous data set. So I'm going to press Stat. I'm going to choose option 4 to clear the list, and it's in list 1. So I'll press the second button and the number 1 and press enter. And that's kind of like erasing list 1. So then I'm going to go back to Stat again. And again, I'm going to edit because I need to enter this new data set. So I have 5, enter, 3, enter, 1, enter, 1, enter, 1, enter, 3, enter, 2, enter, 3, enter, 0, enter, 5, enter. Okay, so I get them all 10 of them entered. Now I'm ready to calculate my confidence interval. So we go Stat, arrow to the right 2 times, highlighting the word test. I want option 7, which is a Z interval. Again, I've entered my data. I need to enter my standard deviation, which was 0.44. My data is again in list 1. Frequency defaults to 1. Confidence interval we want is 95%. And I'm going to calculate. And the numbers that I get from the calculators, and I'll pull it back up in just a minute. Okay, the number we get from the calculator we have, and I'm going to write it above my problem here. Okay, we have the numbers. Sorry, let me pull it back up one more time. Is 2.17 or 1273, comma, and 26727. So 2.6727. This time the question asks us for the lower bound. Remember, the first number in the parentheses is my lower bound. This is the lower bound. We need 2 decimal places. So in the second decimal place, there's a 2. There's a 7 next door, so it rounds up. You get 2.13. Okay? And then I think I have an example of the other type. Okay? So let me scroll down. It says, in a simple random sample of 63 electronic components produced by a certain method, the mean lifetime was 1,047 hours. Assume that the component lifetimes are normally distributed with a population standard deviation of 161 hours. What is the upper bound of the 95% confidence interval for the lifetime of the confidence intervals? Okay, so again, in this problem, it really gives me everything. It tells me initially that my sample size is 63. It says the mean lifetime was 1,047 hours. So that's X bar. 1,047. See, I'm not given the raw data here. It does tell me that my lifetimes are normally distributed with a population standard deviation of 161. So sigma is 161. And my confidence level is, again, 95%. So in this problem, I've actually been given all of the information outright. I'm still going to use that z-interval command, but I don't have to worry about entering my data into the calculator first because I don't have the data. Okay, so that changes some of the keystrokes just a little bit. Again, we go to Stat. We arrow to the right, highlighting the test menu. We choose number 7, again, because we know the population standard deviation. Okay, but this time instead of data, I want to enter the stats. So I'm going to arrow to the right and highlight the word stats. And after I highlight it, I need to press enter. So that now you have kind of the word stats blinking at you. And it asks you for the information. And I want to make sure I remember the population standard deviation correctly. So let me minimize this for just a minute. 161. Okay, so I'm going to pull the calculator back up. So I'm going to, my population standard deviation is 161. The sample mean given in the problem is 1,047 hours. We had 63 in our sample, and we're doing a 95% confidence level. Okay, so this time I have to highlight the word stats because I've given all the information. I don't have the raw data. So I enter all of the information that's given in the problem, highlight the word calculate, press enter. And it comes up and it gives me 1,007.2 for my lower bound, and my upper bound is 1,086.8. Okay, so my upper bound is 1,086.8. Let me make sure I remembered it right. Yeah, 0.8. It didn't indicate here what to round to, but you want the upper bound. The upper bound in this problem would be the 1086.8. You could enter it just like that, assuming it wants one decimal place. If you wanted to round to the nearest whole, that would be 1087. I will point out to you, just as a heads up, in lesson 17, you begin looking at confidence intervals where you do not know the population standard deviation. And in that case, you're going to do very similar process, but you're going to use a T, as in tiger, interval rather than the Z.